Good morning, friend. Myself, Chandra Kumar. I am taking the electrical machine. And in continuation of the previous lecture, we are just discussing about the DC machines. Under this, we are discussing the principle of the operation, EMF equation, voltage build-up phenomena in a DC shunt generator. The principle of the DC machine is an electromechanical energy alternation device. The working principle of a DC machine is when electric current flows through a coil within a magnetic field and then the magnetic force generates a torque which rotates the DC motor. The DC machines are classified into two types such as DC generator as well as DC motor. The main function of the DC generator is to convert mechanical power to DC electrical power, whereas a DC motor converts the DC power to mechanical power. DC motor is applicable where the good speed regulation and ample range of speeds are necessary, like in electrical traction systems or the railways, or we are using to transport a heavy loading from one location to the another one within an organization. So this type of DC motor is applicable where the heavy loading application we have just required. The excitation of DC machine is classified into two types, namely the separate excitation as well as self-excitation. Separate excitation means we are just taking a two excitation process and individual excitation is delivered to the rotor side and the stator side. Then in case of a self-excitation, we are using a single source of DC which will excite the both the stator part and the rotor part. In separate excitation types of DC machine, the field coils are activated with a separate DC source. In self-excitation type of DC machine, the flow of current throughout the field winding is supplied with the machine. The principal kinds of DC machine are classified into four types, which include the following: separately excited DC machine, shunt wound or shunt DC machine, series wound or series machine, compound wound or compound machine. So it will be depend upon the types of connections we are providing to the field winding of the machine. With respect to the armature winding, it will be given over the stator and the rotor part of a machine. For a separately excited, the excited DC machine, a separate DC source is utilized for activating the field coil. In case of the shunt wound DC machine, the field coils are aligned in parallel through the armature. As the shunt field gets the complete output voltage of a generator, otherwise a motor supply voltage. It is normally made of a huge number of twists of fine wire with a small field current carrying because it will be connected in parallel with the armature. So the field winding will get in a complete total voltage which will be given to the DC machine in parallel with the field winding. But so that the number of turns we are opting for a DC shunt machine, it will be larger as compared to the thickness of the wire. So whenever we have to identify that the machine is a shunt or series or armature, which one is the armature winding, then on the size of the conductors, we are identified that this machine, this winding will be we are using for the shunt purpose, and this winding is for used for the armature purpose. This will be the structure of the separately excited, where we are getting that there is a two DC sources are there. One DC supply we are delivered to the field winding and another will be delivered to the armature. So there is a separate supply we are opting for this one. And if we are saying that there is a generator, then there is a DC supply will be delivered to the field winding with the separately excited, and we are getting a generated voltage at the volt with the help of the voltmeter across the armature. So we can connect the load over here. Similarly, whenever we have to just look over the shunt winding, shunt DC generator, we are getting that there is a generator, and in parallel of this, there is a field winding usually assigned over here with a variable resistance. So this variable resistance is providing you a variable field current, which will move over this side, and there is a ammeter voltmeter is there, and there is a variable load options are there, so we can increase the load. So this will be the structure. It will indicate that there is a separate. If we are given the separate sources are there, then it will be called the separately excited. If we are given a single source and it does that source will be applicable to excite the field winding in the armature winding, then it will be called the self-excited machine. Then there is a series wound machine. In series wound machine, the field coils are allied in series through the armature. The armature winding always in series with the field winding. As we know that the armature is placed on the status on the rotor side, and the field winding is placed on the rotors on the stator side. So whenever we are looking over this side, there is one winding will be placed on the stator side, another winding we are placed over the rotor side. So we have to make the arrangement in such a manner that the armature and the field winding both comes in a series format. As series field winding gets the armature current as well as the armature current is very huge. Due to this, the series field winding includes a few twists of wire of big cross-sectional region. So as we discussed in the wound rotor, in the shunt wound DC machine, there is a larger number of turns with a thinner size of the wire. But in case of the field winding, as the armature current is very huge is there, so the same current which will be flowing to the field winding. So we are required a smaller number of turns, but the size of the wire will be larger. In another method and another machine, DC machine is the compound wound DC machine. A compound machines include both the series as well as the shunt field windings are there. Two windings are carried out with every machine pole. The series winding of the machine includes few twists of a huge cross-sectional region as well as the shunt winding includes several fine wire twists are there. So this will be the basic differences over here. Now on the basis of their connection, the compound machine will be again uh, again categorized into categories. One, it will be called as a short shunt compound machine. Under the short shunt compound machine, the connection of the compound machine can be done in two ways. If the shunt field is allied in parallel by the armature coil, then the machine can be named as the short shunt. And if the shunt field is allied in parallel with both the armature as well as series field, then the machine is named as the long shunt compound machine. Now, as we know about the different types of machines are there within a DC, so now we are discussing about the EMF equation of the DC machine. That equation can be applicable for the motor or for the generator as well. The DC machine EMF can be defined as when the armature in the DC machine rotates, the voltage can be generated within the coil. In a generator, the EMF of rotation can be called the generated EMF and ER equal to EG. In the motor, the EMF of rotation can be called as counter or back EMF and ER equal to EB. So the rotor EMF, it will be indicated as a generated EMF in case of the generator, or it will be back EMF in case of the motor. Let phi is the useful flux for every pole within Webers. Every poles is the most important thing will be there. That the phi is associated with the every poles. Capital P is the total number of poles are there. Z is used as the total number of conductors within the armature. Small n is used as a rotational speed for an armature in the revolution for each second. Means we are working on a RPS, radian per second, or revolutions per second. Capital A is the number of parallel paths throughout the armature among the opposite polarity brushes. Z upon A is the number of armature conductors within series for each parallel line. As the flux for each pole is phi, every conductor slashes a flux P phi within a single revolution. The voltage produced for each conductor equal to flux slash for each revolution in WB per time taken. for a single revolution within a second, as n revolutions are completed within a single second, and one revolution will be completed within a 1 upon n second. Thus, the time for a single armature revolution is a 1 upon n second. The standard value of produced voltage for each conductor, it will be P times phi upon 1 upon n, or Np phi volts. The voltage produced E can be decided with the number of armature conductors within series. 1. Any single lane among the buses, the whole voltage produced E equal to standard voltage for each conductor X time each conductor times number of conductors within series for each lane. So E become the Np jet phi upon A. This will be the EMF equation of a DC machine, which can be applicable for the series, shunt, or to the compound machine. So this will be the ending of your lectures on the types of DC machines and the operation of the, or finding the voltage buildup in the DC machine. So this will be the end, and thank you for attending the lecture.